A-level biologists, just a quick reminder about our Easter revision courses, which are coming up in a couple of weeks. Make sure you click the link in the bio to access your place now. Last video, we were looking at what happens during depolarization when a stimulus is applied to an axon's membrane. What we're going to address now is what happens after that depolarization has taken place. Remember that the axon has reached what we call the action potential, which means the potential difference across the membrane due to a stimulus has risen from resting potential around minus 70 millivolts to plus 40 millivolts potential difference. At that point, at that reading of plus 40 millivolts potential difference across the membrane, the action potential has taken place and the sodium gated ion channels, voltage gated ion channels, will at that moment shut down. They will close. Now the sodium ions, remember, have rushed in, so they are going to now be trapped inside the axon. What also happens at that point is at plus 40 millivolts, the potassium ion channels now open. Now remember where those potassium ions are at that moment in time. They are inside the axon, but because the gates to them have now opened, the channels to them have now opened, we're going to get an outflux, a movement of those potassium ions outwardly. So while the sodium ions are trapped inside, we're now going to get our potassium ions moving out. Again, that's a type of facilitated diffusion. Now, as those potassium ions move out, that loss of positive charge from the inside of the axon to the outside of the axon is going to lead to a drop in the potential difference across the membrane, and we call that repolarization. Now, the repolarization actually goes beyond the normal resting potential of minus 70 millivolts. It becomes even more negative than normal to around minus 80 millivolts potential difference. And that's because there's a slight overshoot with how many potassium ion channels are open. They're open for a little bit longer, for example, than the sodium ion channels were. So we get more potassium ions leaving compared to how many sodium ions entered during depolarization. It's quite complex, but basically that is what's happening during the repolarization of the axon's membrane.